Hello there, Anthony Hammond here with a brief introduction to using the UKFE R package for estimating peak flows. To start using UKFE, for implementation of the Flood Estimation Handbook methods, we first need to install R and RStudio. Well, RStudio is optional, but it's very handy. It's very simple to do. Essentially, we Google it. So type into Google, install RStudio. You'll get a link like this, RStudio desktop. Click on that, and if we scroll down, there are two components. There's install R and install RStudio. We need to install R before we can use RStudio. So you click on the download and install R, and once that's done, you click on the download RStudio desktop for Windows, and then we're ready to roll. Now, when you click on these, you'll probably have to choose a place to save your install, but aside from that, it's just a case of clicking OK, and hey presto, it'll be ready to roll. And an icon will be saved on your desktop. Now, once we've done that, we can open up the RStudio environment, and it looks something like this. And to use UKFE, we can type in install.packages, which we'll need to do, like so. I won't do it now because I've already installed it. Now I'm typing into the console here, which you can do directly, but another option is to type up here and put your cursor on your line of code, click Control and press Enter, and it will automatically go into the console. Now, we only need to install.packages once, and then the package is installed. But every time we open up our RStudio, we do need to type in library UKFE to make sure we've got it loaded in. In this case, I will do so, like so. Now, once we've done that, we're ready to roll. And to estimate peak flows, there are four main steps. We have to get some catchment descriptors, and we've got functions to do this. And then we estimate QMED using the QMED function. Then we create a pooling group using the pool function here. And then we estimate our peak flows using the pooled data. And that's done by using the pool est function. So all the functions have sensible names, as you can see. Now, the first thing I did was for this is to download descriptors from the FEH web service, and this is the file path to where I saved them. We can save that file path using and I'll call it my file path. So this is the way we save something as an object in R using this assignment value. So my file path, like so. We've now got our file path saved. And if we want to load in the CDs, we can call them my CDs and use the CDs XML function and put in my file path, like so. And there we go. We've now got some CDs to work with, so we can have a quick look at those. This is what they look like, descriptors and the associated value. So we've got a catchment of 15.6 square kilometers, for example. Now, the next step is estimation of QMED. So we use the QMED function. We put in my CDs, and we should get a result like so. And the result is around 15 to 16 meters cubed per second. Now, that's the sort of standard default result, but we can also use donor adjustment. In this case, we can just type a number of donors. We'll choose 8. And we can return the details by putting return details equals true. And we get a slightly different answer, which is 15 meters cubed per second, essentially. And because we put return details equals true, we also get the details of the donors that we applied. We got the ID and the observed data, distance from catchment centroid, and all that sort of jazz. So we'll save this. By the way, you can also, instead of the number of donors, you can also choose, I won't do that, specifically the donor IDs you want, if you so choose, if you've, there are functions to search for donors, but we won't go into that now. For now, we'll save our estimate of QMED, assuming that we're happy with that, and call it my QMED. Now, the next step is to create a pooling group. So we'll call it my pooling group, or just my pool for now. It's simple, and we use the pool function, put in my CDs, and there we are. We have a pooling group ready to roll. And these are the details. So the row names of the pooling group are the gauge IDs, and then we've got as the column headers the catchment descriptors and other details such as the LCV and LSQ, and then the associated values within the pooling group. Now we've got our pooling group, we're on to the fourth step here, pooled estimate. Of course, there are lots of options you can choose with the QMED function and the pool function, and we can change our pooling group and choose different distributions. Here we're just going to use the default, and the default distribution, for example, is the generalized logistic distribution. So we're assuming we're happy with our pooling group, and we can now have my result. So pool est, put in my pooling group. Oh, something's gone wrong here. Handy in this package is when something goes wrong, hopefully it tells you what you're missing. So you can't just put in the pooling group, you have to put all these other things into for the pool est function. So this is saying the CD's argument is missing. So we've stuck in my pool, we need to put in our catchment descriptors. So we called them my catchment, that's why it's good to save these things as objects. Very handy. Stick in my C's. We also need to put in the QMED. So QMED estimate. Let's put in my QMED. There we go. And I think that should do it. There we are. Takes a couple of seconds to estimate the uncertainty, and we have my result, and it looks something like this. So first of all, it comes in a list form with a few elements. The first element is the results. Here we are. So we've got return period on the left-hand side. We've got flow, growth factor, factorial standard error, and we've got the weighted L moments with LCV and LSQ and distribution parameters. All the information we need in all our peak flow estimates. Excellent. So that is how we do it when we haven't got observed data. Sometimes we have an observed annual maximum sample from a gauge, for example. In which case, the process is pretty much the same, but we get our catchment descriptors in a slightly different way using the get CDs function instead. So instead of my CDs, we'll call it my CDs gauged, and instead of CDs XML, we use get CDs and put in the gauge number. Here we'll use 71001 as an example, which is a gauge on the Ribble, and then we also get the QMED differently. We don't have to estimate it using the QMED function and the QMED equation. Instead, we get it from the observed data. In this case, we'll call it my QMED gauged equals get QMED. And again, we just put in the gauge number. And in this case, my QMED gauge is 122 meters cubed per second. So exactly the same aside from that. Now, before we finish, so we've got all our peak flow estimates now. Before we finish, I'll just say that there's loads of functions within the UKFE package, and to see how to use them and to see how to use these current functions that we've already looked at in more detail, we can click on this up here, which is called packages. Type UKFE in here, it's already typed in, but we've got a whole list of packages. If you type in UKFE, it'll pop up, click on it, and it'll give you all the details with all the functions listed. And you can click on any one of these functions and it will give you all the information you need and show you how to run them, including examples. So that's it. Thank you very much.